Today we will discuss the topic thermistors in measurement and metrology. First of all, we discuss in thermistor the construction and working of thermistor. Thermistor is made of two words, thermal and resistor. That's meaning is the to resist the thermal or the temperature. They are made of by semiconductors which behaves as a resistors with a high negative temperature coefficient. If the temperature increases, the resistance goes up or increases. This is just opposite to the effect of temperature changes on metals. A high sensitivity to temperature changes, that is decrease in resistance as much as 6% for each 1 degree centigrade rise in temperature in some cases, makes the thermistors extremely useful for precision temperature measurement, control and compensation in the temperature range of 100 to 300 degrees centigrade. The thermistors are composed of metal oxides. The most commonly used oxides are those of the manganese, nickel, cobalt, iron, copper, titanium, etc. The fabrication of commercial NTC thermistors uses basic ceramics technology and continues today much as it has decayed. In the basic process, a mixture of two or more metal oxide powders are combined with suitable binders, are formed to a desired geometry, dried and sintered at an elevated temperature by varying the types of oxide that is used and their relative proportions. The sintering atmosphere and the sintering temperature, a wide range of sensitivity and temperature coefficient characteristics can be obtained. Metallized surface contact thermistors include the following, that is bead, discs, chips, washers, rods. If we talk about the bead type thermistor, then the smallest thermistors are in the form of heads with a diameter of 0.15 mm to 1.25 mm. This is the most familiar type of thermistor, usually glass coated, that is shown in the diagram. That is the thermistor which is glass coated, and this bead type thermistor include the following: bare beads, glass coated beads, ruggedized beads, miniature glass probes, glass rods, within glass enclosures. In the disc type thermistors, if we talk about this type of thermistor, then we get they are made by compressing a blend of oxide powder in a round die using presses similar to those used for making powdered metal parts or pharmaceutical tablets. The green discs are then sintered at high temperatures. Next, if we discuss the chip type thermistor, in the NTC, chip thermistors are usually fabricated using a tape casting or doctor blending process in which slurry of material is sprayed out into a thick film set similar to the process used for making chip capacitors or ceramic substrates. The ceramic sheet material is then subjected to a controlled drying cycle. In the green state, the sheet of material is reasonably flexible and easy to handle. The dried material is then cut into slabs or squares that are stacked on ceramic setter, sand sintered at high temperatures. Next one is rod type thermistor. These types of thermistors are made by extruding a mixture of oxide powders and a suitable binder through a die. Their greater mass, longer thermal time constants, and higher dissipation constant makes them suitable for applications involving temperature compensation, time delay, or suppression. Next one is washer type thermistors. In the washer type thermistors that are fabricated using techniques similar to those used for discs, except that a hole of formed in the center during the pressing operations. Washers are usually connected to circuitry by means of spring clips or other hardware. These all are we can see in the diagram that is shown in the figure clearly. Okay, thanks.